Okay, your final exam review. Number 1, convert 11 pi over 20 radians to a degree measure. So we're going to have to remember, if we want to convert it to degrees, we got to get rid of radians. So we're going to multiply it by 180 over pi. Remember, 180 is degrees, pi is radians. If we want to get rid of radians, then we need to put radians in the denominator, and it just works out. So 20 goes into 180 9 times. 9 times 11 is 99. So it's option C. Number 2, got a circle. Radius 21. Cuts off an arc of 50. I have no idea if this is to size. It probably isn't. But it's saying find the central angle, that. And I'm going to use r theta. Remember, we have s equals pi r theta over 180 also, but this is way simpler. There is a risk here, though, because as you can see, we got radians, 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 degrees, degrees. We don't know whether picking this, remember, this is going to be in terms of radians. This is going to be in terms of degrees, but I'm picking this one. So the arc length is 50. The radius is 21, and I don't know what theta is. So I'm going to divide by 21, divide by 21. So I went ahead and calculated 50 divided by 21 is 2.38. And again, that's radians because I used this formula. And I hope and I pray that I find it, and there it is, letter C. The question is, what if one of these three were not the correct answers? Then I'd have to convert this radian answer to degrees. Now, I'm not going to finish it because I've only got so much time, but that's where I'd have to go 180 over pi and then convert it to degrees. That's a what if, but don't worry about it because it didn't happen. We actually found letter C. All right, so number 3, I've got the drawing drawn for you. It says, let theta be an acute angle right here in a right triangle, so we know that's a right angle, where cosine, remember cosine is adjacent over hypotenuse, and that's why I put the adjacent side 4, hypotenuse 5. It says find tangent. Well, tangent is opposite over adjacent, which means I got to figure out what this is. Well, if we dig into our bag of tricks from geometry, I can see this is a 3, 4, 5 family. So then I can put the opposite is 3, adjacent is 4, and there's my answer, 3/4, which is letter B. Number 4 says find cosine of theta, which we know is adjacent over hypotenuse from SOHCAHTOA. And it tells us basically standard position, which is referring to the spinner, whose terminal side, it just means it ends. I don't like this passes through. It should mean stops at 8, -15, okay? So here's my drawing. Here's my spinner. It stopped right at 8, -15. Now my drawing's not to scale. I apologize. But we should be able to recognize from geometry, either using families or Pythagorean theorem, 8, 15, 17. And we think, okay, the problem wants us to find cosine, which is adjacent over hypotenuse. That'd be 8 over 17, which would be option A. Okay, so number 5 is asking us to evaluate tangent of 300. As you can see, none of these are given to you in terms of decimals, so you can't really use your calculator. The intentions are is that you do something like this. You spin your spinner 300, so there's 270 plus 30, and there's 300. But how do I create my right triangle? I never come back to the y-axis. Don't forget that. Always go back to the x. And then I think to myself, okay, well, if this is 30, that means this has to be 60, leaving me with 30 here. So here's my 1, negative square root of 3, and this hypotenuse is my 2. So what would tangent be? Well, tangent is opposite over adjacent. So that would be negative square root of 3 all over 1, which is just negative square root of 3, which is option D. So number 6, I've kind of got a little head start here. I look at this problem. Pi over 6 should jump out at you, and pi over 6 is 30. So 11 times 30 is 330. That's telling you how far to spin your spinner. So there's 270 plus 60, leaving you with a little sliver of 30 there, and we always create our right triangle going back to the x-axis. Once again, we have a 30, 60, 90 here. So this would be -1, this would be the square root of 3, this would be 2. And it's asking us to find sine, which is opposite over hypotenuse, which would be -1 over 2, and which is -1/2. So number 7, we have to spin our spinner negative, which means down 270 degrees. Now where did I get that from? Well, pi over 2 is 90. 90 times 3 is 270. Negative means down. So I've got my drawing right here. See, the problem is this is one of those problems where you have to use your imagination if it stops right on one of the axes. So I go just past it. There's my spinner. Go back to my x. And I can realize that my little sliver of a side right there, the one that disappears, is my adjacent side. Now cosine, by definition, is adjacent over hypotenuse. And you see my hypotenuse, which is my spinner, can be anything. It can be 1, 2, 10, doesn't matter. It's some number. Important thing is I know that my adjacent side is 0. And what's 0 over any number? It's just 0. So that would be option C. Okay, number 8. The problem says solve sine of some angle. Now, if you put a theta in there, it might help your brain understand that x is actually representing an angle, which we use theta also. So it says solve for the angle in the interval where your angle, or how far you spin your spinner, can be greater than or equal to 90, less than 180. You don't ignore this clue, it's huge, which takes us right into this quadrant. So I know that my opposite needs to be the square root of 3, and my hypotenuse needs to be 2, because sine is opposite over hypotenuse. So I try to draw this somewhat to scale. There's my square root of 3, there's my 2. And you see these dimensions, we've seen them enough to where we should say, aha, that needs to be -1. So this is 30, making that angle right there 60. And that'd be tempting to look for 60 in here. It really would. But that's not what they're asking. They're asking, how far do you have to spin your spinner to get this picture in this window? And the answer would be 120 degrees. Now notice they're all radians. Well, here's how your brain should work. 60 is pi over 3. So 120 needs to be double this, or 2 pi over 3. And that would be option A. So we're up to number 9, which is a sinusoid problem, which is a fancy way of just saying graphing. If we look at the multiple choice options and just kind of think of this backwards, they're asking for the period. So we got to understand the period, which the formula is right here. And then the amplitude. Amplitude's right here. So all the other stuff we don't have to worry about because they're not asking us about it. So process of elimination. Let's deal with the easiest part. Here's my A. So I take the absolute value -4, which is just 4. And now I eliminate possibilities that don't have the amplitude as 4. So now I know I'm down to 2 options. You can take a 50-50 crack at it, but let's dig in a little deeper. It's asking for the period also, and here's the period formula. So you need to understand that we take the 2 pi, put it over our b, reduce it, pi. So we know the period needs to be pi, which is option A. Okay, so number 10 is very similar to number 9, but they're asking us for different things. See, they have a horizontal shift section that we need to be aware of, and that formula is C over B. And vertical stretch is the same thing as amplitude, just a different sort of way of thinking of it or talking about it. Remember, a stretch is if A is greater than 1. It's a shrink if A is less than 1. So because this is so easy, using the absolute value of A, and we know that A is 2, we know that the absolute value of 2 is 2. So we can eliminate quite a few of these options right off the bat because we know that it's a vertical stretch factor of 2. Now these both say vertical stretch, so either one of these might be our correct answer. So that's how they're forcing us to figure out whether it's a horizontal shift right 3 pi or left pi over 3. Now if we really wanted to get fancy on this one, we could remember that plus always means left, minus always means right. So really, we could just go ahead and say, well, the only one of these that says left is D, so that's my answer, and move on. However, let's get a little bit more precise. And it just says, the formula is C over B. So in this case, C is pi over 3. B is just 1, which is just B pi over 3. So that would solidify the fact that it's a horizontal shift left pi over 3. So number 10 is D. Okay, so number 11 is going to be the last problem that I squeeze in on this video. And then we'll start up on number 12 on the next video. I just want to make sure I don't run out of time. So this problem's giving you same sort of question, but they're giving it to you a little differently. They're asking you to get all the information you can from the drawing and try to connect it to one of these equations. So one of the clues that jumps out at me, and remember what A is. A is the amplitude, because amplitude is the absolute value of A. And if you just look at this, you can see that the amplitude is 1, which we would refer to as normal, but what it's saying is A equals 1. So we get a little excited about that, and we look for all of our possibilities, and it's a little bit of a bummer because every single one of these has amplitude of 1, so that didn't help us eliminate anything. Now, a couple of different clues. Back when I showed you sine, when I said y equals sine of x, I said one of its signatures is it goes right through the origin. And as you can see, this goes right through the origin. Yes, it's going up a little steeper, but it's going through the origin. So that means A is not negative. In other words, if A was negative, it would flip everything and it would go through the origin differently. So I can eliminate this one, and I can eliminate this one. But now comes the tough challenge. You need to look at this and understand that the normal period for sine is 2 pi. And what needs to jump out at you on this problem is this period has been horizontally shrunk by a factor of 2. Now, having said that, that doesn't help you much because you got to know what equation does that. Well, if you look at the period formula, how do we get this to equal pi? Because as you can see, that is the period of this yellow portion. And the only way you can get from 2 pi to pi is if we turn this into a 2, because it would cut it in half. So in other words, we're saying the only way is you can let b equal 2. So I look at this one, looks good. This one has b as 1/2, not good. This one, b is 1, not good. So letter E would be my correct answer, but that one's a little bit of a challenge. And that's it for this particular video. I'm going to start the next one at number 12.